In this video, we're going to prove integration by parts. So more precisely, if u and v are real-valued functions on an open set of R containing the interval from a to b, and if u and v have continuous derivatives, then the integral of u of x v prime of x dx from a to b is u of b times v of b minus u of a times v of a minus the integral from a to b of v of x times u prime of x dx. So this is often abbreviated by writing the integral from a to b of u, and then v prime of x dx is often written as dv. And then this constant is often written uv from a to b, and then minus the integral from a to b, and then v of x is v, and the u prime of x dx is du. So the integral of u dv is uv minus the integral of v du. That's often how it's phrased. So let's prove this. Well, the idea is you move this to the other side, and then you have some integral. So since u and v have continuous derivatives, u of x times v prime of x plus v of x times u prime of x is integrable. Right? Because u and v are continuous, u prime and v prime are continuous, and so this whole function is continuous, and therefore it's integrable. And by the product rule, we know that the derivative of u of x times v of x is equal to u of x times v prime of x plus v of x times u prime of x. So, by the fundamental theorem of calculus, the integral of u of x times v prime of x plus v of x u prime of x from a to b is just equal to, you take the function uv and then plug in b and then subtract what you get when you plug in a. So it's just u of b times v of b minus u of a times v of a. Well, we can split this up. We can split this integral up into the sum of the integrals, and then we get that u of x v prime of x dx, the integral of this, is equal to, well, we just subtract the integral of v of x u prime of x dx from both sides. So it's just going to be u of b times v of b minus u of a times v of a minus the integral from a to b of v of x u prime of x dx. And that's the proof. So a very short proof. I mean, integration by parts might sound complicated when you first learn it, but in reality, it's just because when you take the derivative of u times v, you get this, and then when you move this integral in the sum to the other side, then you just get the minus integral of v du. And that's the proof of integration by parts.